Thanks everyone for joining us for the webinar Scaling Data Vault for Federated and Data Mesh Architectures. We have our guest speaker here, Kevin Marshbank, CEO and Principal Consultant of the Data Vault Shop. He has a lot of information to cover, so we're just going to kick it off and jump right into it. Kevin, I'm going to hand it over to you. Thanks for joining us.
Awesome. Thank you, Courtney. Appreciate it.
Mhm.
Well, welcome everybody. Again, as Courtney said, we're going to be covering decentralized architectures, data mesh, and federated specifically, and talking about data vault involved with that as well. And I'll just go ahead and jump in here. I have a lot of content to go through. So do an introduction, uh, talk about the decentralized trends, rising decentralized trends, and some things around that. Why has that come back up as a topic? And pontificate on that a little bit. Then we'll talk about a couple of the main decentralized approaches around methodologies and how people approach that. Then we're going to jump into challenges in those decentralized architectures. So there's obviously challenges in centralized and decentralized. Some of them will be common across both of those, but we will be discussing those. Data Vault 2.0, we'll talk about how Data Vault 2.0 helps in both those decentralized architectures as much as it has helped in your centralized architectures as well, and some specifics around that as well. So some specific items in Data Vault 2.0 that you will want to pay attention to that will help that process tremendously. And then we'll talk about some additional best practices for decentralized design, and then accelerating implementation, specifically data automation, and how that can help those teams in those scenarios. And then we'll be talking about some key takeaways, some next steps, and then Q&A. So Q&A, go ahead and feel free throughout this webinar to submit some questions, and we will, given time at the end, happy to field those and talk through those as we have the time to do so. So please shoot as many as you can at me. I'm happy to talk about whatever items you would like to bring up, even if they're maybe off in the weeds a little bit. So who is the Data Vault Shop? Well, I'm Kevin Marshbank, and I've been doing data warehousing for several decades, as much as it pains me to say that. I'm a WhereScape partner with deep experience as a former WhereScape customer, then also a WhereScape employee and a WhereScape consultant as well. And as I mentioned, decades of experience in data warehousing across all the various flavors of data warehousing. Like most people, getting the start in Kimball methodology, providing it's a small boutique consultancy, and we provide customers expertise in the design and implementation. And really, our focus is to train up the teams as well so they can take over and continue moving forward on their own as well, and automating a lot of those requirements along the way. We do have some customers that require ongoing support as well, and that's available. And then breadth of experience across most methodologies. So I mentioned Data Warehouse 2.0, Kimball, dimensional modeling, EDW, bitemporal, etc. And then implementation experience on most platforms. So Databricks, Snowflake, XSL, SQL Server, Oracle Exadata, et cetera, et cetera. Obviously, over the years, lots of various platforms. So let's jump into rising decentralized trends while you're here. And I put on here revisited anew. And the reason for that is that there's an ebb and flow of centralization to decentralization. And that has been going on for quite some time, from mainframes with dummy terminals to the rise of the PC and decentralizing the processing on those PCs. And then also with web servers, centralized web processing, and then moving a lot of that processing decentralized via JavaScript, CSS, et cetera, to the individual browsers to process some of that as well. A lot of other technologies in there. We're not here to discuss all of those, but I've had my hands in lots of different pieces of that over time, not just data warehousing. And so we'll talk about decentralization today in data warehousing and why that is coming back up. And some of these, depending on how long you've been in the industry, will seem very familiar. But what's the purpose? Distributed data ownership and processing. So moving that ownership to the groups that need that data. So that could be distributed by locale. So it could be by nation, states, legal or governmental jurisdictions that either require that or it's simply a matter of parsing out that ownership to those areas. It could be organizational, could be legal entities. So I worked for an organization that was a large multinational with 5 distinct businesses that were their own legal entities as well, operating underneath that umbrella. And they had defined separations for those. It could be simply be divisions within a large organization, or smaller organizations might just be departments. And then also geographic or continental parsing of those domains out. And I worked for another organization where we had data centers in different on different continents simply for data latency processing of that data locally so that the response times would be much faster. So each of these segments is referred to as a domain, and you could be separating this by one of these categories or multiple categories, and that depends on your organization and what works best for your org. Domains manage their own pipelines and storage, and realistically end to end. The whole goal there with, and well, again, we'll talk about federated and data mesh, but the goal is that those domains are going to be managing those that infrastructure for their domain. And that should, or at least it's purported that those teams can run faster because they're not being held up by central IT bottlenecks, putting in requests, waiting for responses, approvals, all those other things that come along with centralized teams. Also, in those domains, the domain experts can build relevant data sets for their business context. So they're going to typically be able to focus specifically on the needs of that domain and provide results, a faster time to market and ROI on the things they're building for their particular businesses. Continuing decentralization isn't new. Again, I mentioned some of the other things over time, but the interest has been revitalized. Data mesh published this year. The paper was actually published this year on data mesh, but the concept has risen. And anytime you put a name around something with some standards, some specification, it definitely gets more interest as it's more of a real concept at that point, and people can use that as talking points to bring to their leadership and articulate some solutions to some pain points that they've been experiencing. Again, frustration with centralized IT and data warehouse teams and their ability or lack thereof to deliver quickly and specifically to the needs of those particular domains. And depending on the domains, they may feel ignored. The data sets they're interested in aren't the ones being prioritized, et cetera. Performance of centralized data warehouse platforms. So, as the data gets loaded into the central platforms, there may be large volumes of data coming in from various domains that may or may not be pertinent to other domains. And just as the performance gets reduced, if whether, ill-advised focus on virtualization that doesn't perform as well as promised, lots of various things, improper design, uh, poor methodologies that don't scale well, those data platforms can suffer. And yes, even on Snowflake, I've come into organizations and had to resolve situations where running on XL warehouse could not process their warehouse loads over the weekend. So improper design can torpedo almost any implementation. Financial burden, allocating shared costs to cost centers. So in large centralized environments, sometimes it is difficult or a lot of hard conversations around what various domains are paying for, what cost centers those are getting allocated to, and whether or not they feel like they're getting the ROI that they expect from their investment. Also, along this path, along with these same concerns in AI, local LLMs have started rising in interest. Instead of paying for the cost of all these tokens running against GPT, Claude, Sora, etc., taking those LLMs, local LLMs, locally on local hardware, cost savings around that, privacy, as well as being able to customize those implementations for the needs of those particular domains, versus large models that are doing a lot of additional work that aren't pertinent to whatever they're trying to solve. Legal jurisdiction over data. So that's no longer just large multinationals. As I mentioned, small to medium-sized businesses are working globally now, and so there's concerns that they have to worry about as well. And data volumes continue to accelerate. So um, this is a big one. We keep hearing about it, and to put some real numbers on it, numbers are getting kind of crazy. To date, by the end of 2025, we will have collectively over time produced and stored 181 zettabytes by the end of 2025. That is a lot of data. So beyond exabytes, we're talking zettabytes now, and that's projected to be doubling every 4 years. So that means in 4 years, 2029, we're talking 362 zettabytes of data. In numbers, that's about 7.2 billion. 181 zettabytes is 7.2 billion full-length movies. So if you sat down, it would take you about 1.6 billion years to watch all of that. And in 4 years, you would have 3.2 billion minus 4 years of video to watch. So have fun with that. That's not something you're going to be able to catch up on, regardless of the YouTube binging that you're doing. Primary centralized approaches, decentralized approaches. So we're going to really cover the two main ones. We're going to talk about federated approach first. So here you can see the diagram to the right over here. Pointer. So you can see this centralized warehouse. It's a virtual warehouse in a federated approach that is accessing the domain-specific warehouses that are processing the data in their particular domains. And that's a virtual access layer. So the really nice thing with that is the pipelines governance are all maintained by those domains, and the access to that data is governed by those federated warehouses so that compliance is localized to those areas. The main thing there is keeping those APIs up to date as things change. So there are complexities in governance. So in the warehouse, virtualized warehouse, how that data is aggregated and combined with other domains and that sharing of that data around. So definitely some complexities there around legal jurisdictions. And then the other nice thing about that is that costs can be more clearly allocated to those domains because that information is being, or the domain is in control of producing end-to-end their pipelines and processing, and it's just the virtual access from the centralized data warehouse. So continue on that, a little bit different of a diagram here that's kind of exemplifying this globally. We have our federated warehouses around the outside here and feeding that data to, or not feeding, but virtualized access to this centralized warehouse here. And the scalability is one of the nice things is scalability can be addressed at those domain levels. So warehouse A does not need to have the same size and scale necessarily as a federated warehouse over in this area. And as those needs increase, they can scale up their particular areas as necessary versus scaling up a centralized warehouse that's consuming data from all the areas. And in that case, increasing the cost to other domains that may not be contributing to the increase in scale. Domains have varying levels of freedom within this architecture to implement the tools, the platforms. There are in these federated approaches, you can have some warehouses running on Azure, Fabric. You could have others running in AWS on Snowflake. You can have some that have local installations of SQL Server or Postgres or whatever platforms are um, the best fit for those particular areas. Flexibility to more easily adapt to domain-specific changes. So if there are changes to uh, jurisdictional changes, legal changes in one area that only apply to this warehouse, those can be implemented there, whereas there may not be any changes over here or very different changes happening in this federated warehouse, as well as additional sources being fed to uh, this particular federated warehouse that don't impact the others. And so they don't have to worry about implementing that or incurring any cost related to those other sources that are specific to only one or a few of the federated warehouses. Now, as far as this diagram, you can see these are all floating around the Earth. That's not unintentional. That's something for us to actually consider very soon. So Google's Project Suncatcher is one of them. There are actually many others that are further along. And as a segue here, we'll just take a little detour and talk about federated in space. So there is actually a company called StarCloud, and their intention is this coming year to have a first data center in space that is accessible 24/7. And one of the beautiful things about a data center in space is it is cold. And so thermal management is a lot easier. There should be a lot of benefits to that. And this is a diagram of what that looks like. And just, there's a lot of things out there as far as like ideas that aren't realistic or even going to come to fruition. They're just trying to get seed money. But let's take a look at this. This is StarCloud 2. It's talking about providing data center access to in-space assets. So that would be things like this Hubble telescope or the space station, International Space Station, or other space stations, being able to provide support to on Earth, or as we're now calling it, terrestrial assets. And then also third-party backhaul network, which they don't state here, but that's most likely going to be SpaceX's Starlink network. And lest you think this is just all pie in the sky, they just launched their first satellite last week, November 3rd. And here's a photo of it floating around in space. So this one is StarCloud 1. It's their test bed, but they are actively testing that. It was successfully launched, and it is orbiting Earth right now, doing their first test cases with it. So yes, that is coming and coming soon. And let's talk about some of the things that actually do matter in the federated and data mesh space around that. So they are talking about in-space users. And if we take a look here, they're talking about, again, I mentioned space station, spacecraft. Think about Hubble telescope and all the image processing and all the other satellites that are either taking videos and photos of Earth or of the sky and just processing that in an in-space data center instead of needing to send it to Earth. But one of the things that I really think that we need to see and pay attention to is this part up here. So terrestrial users of these data centers. It's providing a sovereign cloud computing fully independent of Earth. So that is an important statement when we're talking about legal jurisdictions. You now have a sovereign, independent of any nation, cloud computing in the sky. So however that may apply to your organization, that is something to be or to take notice of. So back down to Earth on talking data mesh. Let's talk about the 4 pillars of data mesh. So again, this has been a paper published. I'll have the link later in this presentation to the data mesh paper, but we're going to talk about the 4 pillars here. Domain-oriented data ownership. So we've talked about domains already, and this empowers teams to make decisions about their data, the structure, quality, accessibility, etc. Again, we'll come back to that in a few minutes. Self-serve data infrastructure. So these domains have their own decisions to make around which tools and platforms are necessary for their particular mesh implementation. So again, so there's some autonomy here, and we'll talk about things to consider in that autonomy and how autonomous these different data mesh participants are. Federated governance, a framework for establishing and enforcing standards across all domains, and that's a really important one. I'd really sit on that one as far as data mesh. Federated data mesh is great, but there is some, and I'll come back around. I mentioned it later. I'm just kind of pontificating a little bit. It is important to be aware of um, some control around data quality, around governance, jurisdictional concerns, security, privacy, etc. The fourth, sorry, I jumped ahead there. Fourth item in the pillar for data mesh is treating data as a product. So this is one that a lot of data professionals in the industry we've been talking about for a while and trying to advocate for is treating data as a product. So I'm really glad to see this on one of the pillars of data mesh. Especially the data that you have about your customers or your products, that is um, information that others do not have. And that is really the value that you bring that nobody else has. So treating that information that you know about your interactions with your customer, their interactions with your products, your services, that's proprietary information that is not commodity information. That's not available out on networks. It's not like demographic data that you can go purchase or census data or things like that. And really taking advantage of that and treating that as a product. And that's important also in a mesh environment when other orgs, other domains within your organization are collecting data that you may not have that they can share back with you, given legal considerations, et cetera, that could help augment and provide additional advantages in how you're dealing with customers, I mean, getting new customers, managing services, et cetera. So those pillars, and again, my description there is kind of summarized, brief of what those pillars are, but they're not rigidly defined. So that allows the implementations to be customized to your organization. How the data product is handled as a data asset across the various participants in the data mesh is not homogeneous. There may be differences in procurement, so how the data is sourced, your data warehouse methodology. So there may be a mix of Lakehouse, Data Warehouse 2.0, Data Vault 2.0, Star Schema, operational data store by temporal, et cetera, et cetera. There could be a myriad or uh, a mix of those in the various mesh implementations. Data egress, so data coming out of those, how they provide that data out through BI, reporting, data sharing, APIs, et cetera, may be different based off of the skill sets, platforms, et cetera, that are implemented in those various areas. So let's talk about some challenges of decentralized approaches. So data standardization, maintaining scrutiny in the data quality and data presentation and schema consistency is difficult, especially as autonomy for those domains increases. And it's important to maintain that as much as possible so that integration of that data is easier, especially when cross-domain, and we'll talk about cross-domain in just a minute, but as reporting, especially in a federated virtualized warehouse, bringing that data together makes it a lot more difficult if data quality, presentation, the methodology that they're using to implement the warehouse is not consistent. Cultural shift. So if you've been working in a centralized environment and you're migrating to decentralized, or even if you're starting out and you're trying to push towards that, domain stewards need to be assigned, and those stewards need to embrace owning that data domain. And in these environments, that means end to end. So that's sourcing the data, bringing that in, storing it, applying the best practices in whatever data vault methodology, or sorry, data warehouse methodology they're using. And they need to also pull their weight. So there needs to be some commitment to providing that data via APIs to central organizations, to executive teams, to other orgs as needed. But Also, obviously, they need to have the onus to provide the metrics and the data quality to their own domain, their own VPs or whichever orgs they're reporting up through. And accepting that there's going to be varying degrees of success depending on who the stewards are, the teams in place. Training is part of that. So those domain teams have varied levels of experience, skills, and expertise in data warehousing, in let alone data mesh, understanding that. And that's one of the things that was listed on I didn't put it in the slide deck, but difficulties in data mesh implementations is just a lack of understanding and people's commitment to understand what that means to operate in a data mesh environment. One of the other things too is these domains may simply lack the staff or resources. So what do you do in that scenario? And there may be some opportunity for cost sharing, et cetera. We'll talk about a couple other things here. I'll wait and comment on that. Federated data governance. So consistency in data governance structures across domains is difficult, whether it was centrally owned previously or not, and trying to make sure there is a practice across the domains and cross-domain steerings and bring that up. Since the domains are owning that, it's cooperation across those domains is important, especially regulatory compliance, privacy items, security, and that can prove difficult without strong cooperation across those domains. Higher operational overhead. So as you can see, if you're in a data mesh environment and each of these domains is managing end to end, or in a federated environment, there is going to be some duplication of effort. There's going to be redundancy in resources, data engineers, modelers, etc. So there may be some ability to share some of those things, especially when there's a lack of resources in certain domains. But there's definitely potential for higher aggregate cost. Now, sometimes organizations prefer that because the costs at the domain level are clearly aligned with those domains, and there aren't arguments or worries about how to parse those costs out later, and they prefer to have that at the domain cost center. Others may say, this additional aggregate cost is not worth it, or find out ways again with cooperation across domains where you maybe have modelers that are handling multiple domains or maybe all the domains. There's a spectrum here, and I'll come back to the spectrum of centralized versus decentralized. So it doesn't have to be exactly one side or the other. You can operate across a spectrum in decentralization. So let's talk about Data Vault 2.0 and how Data Vault 2.0 helps support environments in a federated or data mesh scenario. So what does Data Vault 2.0 bring? Now, this is not a Data Vault 2.0 training or class, so I'm assuming some understanding. And if you need, you can go to Data Vault Alliance, you can go to my blog on datavaultshop.com. You can reach out afterwards if you need more details, but I'm going to just kind of at a high level go through Data Vault 2.0 and assume some understanding already. The main pillars of Data Vault 2.0 are methodology, architecture, and model. I'm not going to go through all these subpoints here, but it is, as far as methodology, it's consistent and repeatable. That's super important, especially when you're dealing with domains that are running their own warehouses. If everybody's running a consistent and repeatable pattern-based methodology, that is going to greatly improve cohesion and ability to work together in that mesh or federated architecture. The architecture is scalable. So regardless of whether you're running on Postgres, NoSQL, you're running on Snowflake, SQL Server, it doesn't really matter, or a Lakehouse infrastructure. Data Vault 2.0 operates across all of those. I've done Data Vault 2.0 in all of those. That's not, the concepts apply to all of those and in a scalable manner. The model is repeatable as well. Again, that's why we'll be talking about data automation later, but that's another reason I push for this methodology is that so much of it is able to be automated and streamline the what I call the meat and potatoes, like the grunt work of producing the main base of your warehouse is able to be automated. How does it improve data decentralization? So publish standards. So there is a set of standards that all the domains, all the domain owners and the teams can refer to. It's the same standard, and they can refer to that to do their work in each environment, guaranteeing that you're going to be much closer aligned in each of these domains. Training, a standardized DV2.0, now 2.1, I should say, training provides the same techniques and knowledge to all the domains. So you're going to be getting consistent information and direction. Of course, there's always an art to things, and but as far as like being able to look at those warehouses, federated warehouses or data mesh warehouses, and understand what's there and being able to consume that data, get that data egress out will be much simpler as it will be consistent across all of those areas. Community, there's Data Vault 2.0 community, lots of resources, datavaultalliance.com, obviously reaching out to people like myself and many others in the industry, as well as allows collaboration across the domains as they're all using the same methodology, and they can talk about how they chose to implement certain things via Data Vault in their environments. Whether talking about identifying business keys for certain entities, whether we're talking about the ontologies, whether we're talking about how they chose to implement various links, satellites, things like that. Again, we're not going to go into all those details, but a lot of opportunity for community just within your organization across the domains. Scalability, again, is a pattern-based approach based off mathematics, and the scaling is proven over and over again in various platforms that I can attest to as well. So that allows different domains operating on different platforms, different scales of warehouses to not have to worry about the implementation changing based off of the size of the data that they're dealing with. Platform agnostic. So again, can be applied on any platform. And I can go and list all of them, but you get the idea. From on-premise to cloud and across the clouds. So how does it improve data decentralization? Simplifies federated and centralized access to data as the patterns are consistent. So again, I mentioned easier for cross-domain or centralized teams to understand what's going on in each of those areas. Data governance and security. The approach can be similar across domains because of the methodology being implemented. The approach to securing those environments can be consistent. Traceability and auditability, that's built into the Data Vault 2.0 methodology, but that also increases the trustworthiness. We talked about data quality before, and the data that you're receiving from those various participants in the data mesh, the federated warehouses as well, under making sure that that data is accurate is incredibly important, and making sure that it's still a trustworthy set of data that's being combined. So best practices for decentralized design. So we're talking about Data Vault 2.0. I'm going to cover some specific things in Data Vault 2.0, and then we'll talk about platforms. And even though you can have multiple platforms, it is good to be consistent. Iteration towards decentralization and data automation. So Data Vault, first, hashing algorithm. So hash keys are part of the Data Vault 2.0 standard. They're not always required. So I'll just bring that up, like if you're on Teradata, for instance. I'm not going to really cover that specifically, but it's important when choosing your hashing algorithm that it's consistent across the domain. So it allows for that integration of the data passively as you bring this data together across the domains. It allows easy data integration in pit tables, bridge tables, etc. as you bring this data together, cache it up, and combine it and provide reporting. You don't want to have to do a whole bunch of additional business logic, etc., to be able to combine this data and identify whether or not it belongs together. Examples, just as far as what I'm talking about, hashing algorithms, in case you don't know, SHA-2 256, SHA-1, 512, etc. You can do MD5 as well. I don't really recommend it anymore as the performance is better on SHA-1 now on most platforms, and SHA-1's more unique. Data Vault Business Key Collision Codes. This is an important one. It is mentioned in the standard, but let's talk through this. I think this is an important one to cover. This is an additional field that you add in combination with your business key to identify the domain of the data. This allows data to passively integrate or remain segregated as appropriate. So this is something that you would do as you set up the sources. So I've got an example here. It's a real wordy, but let's just, in the US, there's a national provider ID for healthcare providers. And that's a national for the United States identifier. So we would set the BKCC, Business Key Collision Code, to USA in this example. So in that case, you would see the value being hashed as this. So providers from any domain, so across states in the United States, would get that exact same for that particular code, would get that same BKCC, so that that data, regardless of whether that provider was in data from one state or the other, would be able to passively integrate. It would have the same hash key value, and that data would combine without needing an additional work. However, there's for instance, Mexico, they have a different identifier, and we would add the BKCC from there as MEX, as an example, or maybe spell out Mexico. How you set your business key collision codes would be a discussion on standards in your environment. But that hashed value would be this, and that would make sure that even if the identifier, the business key identifier in Mexico happened to be the same, but it's for a different provider, hashed with the business key collision code, it keeps that data segregated even when combined at the same grain level in a provider hub, for example. So that's important if you're going to implement business key collision codes, that you do this across the board for all of the keys within your data vault implementation. Typically, that is set at pipeline design time. However, you could set it dynamically, and typically what I do with customers in WhereScape, I can automate setting what those BKCC values are based off of the source, and then that can be overridden as necessary based off of design time choices. So again, the BKCC is hashed together with the business key, and which produces the hash key, the unique at that grain level for DV2 standards. Business key collision code examples. So we can go through some of these here, but I'll run out of time if I go through this in too much detail. Just, as far as example, it prevents the accidental integration of customers here for the customer hub, business key EIN. Again, this departmental example. We've got a commercial business key versus a residential business key. And if those codes happen to be the same, it keeps them segregated. Whereas in another example with departments, some of the employees may be stored using the same identifier across departments, and you want to mark that as a corporate level identifier so that they can passively integrate. Whereas if it's a different level identifier, that you provide a different BKCC, so those values remain segregated. So it's an important example and really simplifies cross-domain integration. Composite business key consolidation. So this is a scenario where the number of fields that you need to create the same grain level, whether at a hub level or in a link relationship table, may have different numbers of fields involved from different domains or sources of data. So in this case, domain A, to identify a customer, they're using first name, last name, and phone number as the business key. And we're not going to cover whether this really is a great business key or not, but this example here, first name, last name, and phone number combined with the business key collision code of domain A, and then that full value to hash down there at the bottom is what would be actually hashed together in that particular instance from that domain. In domain B, maybe they're simply using email address to identify the customer. And in that case, it's just the email address, and that'll be combined with domain B, and then the whole full value to hash there would be this. And that would keep those um, customers able to be integrated into a combined customer hub. However, still take advantage of the fact that they have different numbers of columns that are being used to identify those grains. Oops, sorry. Accidentally jumped out of the presentation there. All right, so continuing forward with that. So as I mentioned, this holds true for link tables as well. Won't get too much into this, but with the link business key, you may have various numbers of fields involved in the grain of that relationship from domain A, and then different number of fields in domain B as well. So iterating towards decentralization. So when you're moving from centralized to decentralized, you need to take a measured approach in moving to decentralization, standing up the domain teams. So identifying those domain owners and focusing on business capabilities and specific needs for setting up those domains. It depends on environment. Again, this could be legal jurisdictions, it could be specific needs of marketing or operations, etc., and setting up those domains based off of the needs of your particular business. Again, getting domain level ownership and accountability in place for those, and then setting up cross-domain steering committees, federalized governance, architectural standards, access, security compliance. Those all need to be, and at some level, as far as a best practice, is still maintain that in an enterprise level, or at least maintain responsibility for those domain owners that have to answer to a corporate level or some higher level on those items, so that doesn't get lost and ignored across the domains. Set measure goals and timelines, and then adjust and iterate those. And use data quality as a measure of success, and realize that different domains may have more or less success than others, and you'll need to deal with that as necessary based off your organization. So let's talk about accelerating implementation, data automation. So WhereScape, the Data Vault shop, we only use WhereScape for data automation, and a lot of reasons for that. Again, having been a customer and seeing it real time and produce much more than I expected it to actually joining WhereScape, having been so impressed with the tool itself, and then also running as a consultant allows us to work quickly and produce quickly for customers. It does increase developer productivity by quite a bit. My own experience would be like 14x or more. And trust and continuity, metadata driven, it's tracking everything rather than tool handoff. You're dealing with WhereScape tools to model, iterate, coordinate with the business, and produce that data, as well as push that warehouse to QA, to production, and automate that process as well, and CI/CD. And owning your own data, that they're running the data in your platform. So whether you're on Postgres, SQL Server, Oracle, Snowflake, all that's being done in those environments. The data is moving in those environments. WhereScape does not process the data through its own servers or anything like that. It has schedulers, it has metadata repositories for tracking metadata about the information, but all of the data is in your environment. Hybrid process here, we have WhereScape 3D on the left and pushing over to WhereScape Red, some modeling, generating the models, automating the model generation, and then producing and pushing and actually building the actual objects and the ETL code SQL to push that data through, as well as deployment and managing of that. Includes schedulers, scalable schedulers, etc. Tons of customers. Over 1,200 plus customers at this point across the world. And again, a lot of those, depending on the organization, there's multinationals, there's all sorts of industries, healthcare, banking, etc. Reducing Data Vault 2.0 complexity. One of the things I love about the tool is that it has the automation built in for Data Vault, and helps you understand Data Vault as well if you're new to Data Vault. Accelerating development and deployment, consistency, best practices. You don't have to worry about developer A writing code one way and developer B writing it another way. The tool is producing that for you. Platform agnostic. So as I mentioned before, Databricks, SQL Server, Fabric, all these platforms, you can have your choice. And even if you have different domains on different platforms, you can still use WhereScape in those various domains to automate that process. A wonderful thing with WhereScape 3D is that you can have each domain with their own repository. And then you can also have a central team that's producing customizations to automation, naming standards, structure standards, schema standards, etc., and then pushing those out to the domains as well. And they can continue to do that modeling for their particular environment. So key takeaways, next steps, and Q&A. So centralized versus decentralized, talk about that, not right or wrong on centralization for decentralization. It depends on the organization. There's multiple reasons to consider these. Either way, so your organization, team strengths, legal consideration, financial accounting, and yes, even corporate politics play into this as well, which I'm sure you're more than aware. Could even be governmental politics at this point. So it's a spectrum, and the perfect fit along the spectrum of centralization versus decentralization can be anywhere in between, depending on your organization. And then definitely recommend some level of corporate oversight and steering for, again, as we mentioned, security, privacy, compliance, data quality, all these types of things. And depending on your organization, maybe that's not possible, but that's on the far decentralized part of the spectrum. Definitely recommend some level of that. Some things, these are just generic. Some of them are generic, some are specific. Data Vault 2.0, definitely best practice, regardless of centralized or decentralized automation tools. WhereScape, I've used WhereScape in decentralized and centralized environments. Had much success in all of those. A willingness to learn deeply. One of the big things with all of these is really impressing upon your teams to actually embrace whichever methodology you choose, whichever tools you choose, whichever Data Vault, if you're going to use Data Vault, is actually embrace and commit to learning those deeply. And don't get sold by new shiny solutions from vendors. There's lots of promises, and you need to make sure the tools actually have experience. And again, that's one of the reasons I use WhereScape as well. It's been around since 2001. It's been doing this for a very long time with success from the get-go. Experience coaching is always excellent, whether in personal or professional life, dealing with tools, dealing with platforms, methodologies. Have a good attitude, and please share what you've learned with your other teams. Next steps, read a book. So a couple things I really think are important. So Good They Can't Ignore You by Cal Newport. I think this is a huge book, not just for you if you haven't read it before, also for kids coming up. I definitely recommend that. Turning Numbers into Knowledge. I think this is super important for really understanding data that's being provided. So we have we're talking about data quality. This is a good book for really considering how to question the data that's being presented to you and make sure that it is actually good data. Data mesh architecture. Here's the link for the publication around data mesh. You go to that page, and then there'll be a link, or there'll be a button somewhere that says PDF. You can download the PDF for data mesh architecture. And then, really take the time to consider on the spectrum of centralized to decentralized where your organization is, where it should be based off of capabilities and requirements. And again, looking at the business needs in your environment and what those domains would look like and how you would segregate them in your particular organization. And keep an eye on exciting new developments like StarCloud. So starcloud.com, have fun looking at that if you're interested. And now we have time for questions and answers. Courtney, do we have any items to cover?
So it doesn't look like we have any Q&As in the Q&A box, but there is one in the chat that says, is there any differences with Data Vault 2.1 modifications that would be useful?
That is a good question. I think overall, so one of the things, and I didn't really cover this, I covered some things around the technical implementation of Data Vault. So on the model side of things, but people, process, and technology. I have not actually gone through the 2.1 training yet, so I can't answer specifically, but I would presume so. It's a definitely more in depth, and it definitely covers data mesh, federated architectures more. The things that I covered are from my experience in Data Vault 2.0. I'm sure those are probably covered in the CDVP 2.1 classes as well, and probably some more boots on the ground experiences in implementing that well. One of the things Data Vault really tries to address as well is the people part and accountability. Things that people forget that Data Vault 2.0 specifies is that interaction, having the contracts and agreements with the various parties and things like that.
Awesome. Thank you so much, Kevin. There is another question in the question box.
Okay.
WhereScape deployment through Git. What is your experience?
Yeah, WhereScape deployment through Git is definitely possible. I haven't done it specifically through Git, but I have seen customers implement that. WhereScape has extended that impressively. You can also have Git integration directly in WhereScape Red at this point, where it actually pushes the code out to Git. So that's not CI/CD itself. So as far as a deployment process, I've done it with Azure DevOps, and the process is very similar, or very similar. I've had people do it with Jenkins, and I've seen customer, but I have not personally done it with Git. But all the tooling is there, very straightforward. WhereScape has the API in place for supporting that, regardless of which tool you decide to use. I've actually implemented with Azure DevOps 8 swim lanes across multiple environments. So in the end, we're talking 20 environments that were all being deployed through Azure DevOps in WhereScape. So more than possible, and easy to manage once you've set it up.
Thank you, Kevin.
Yep.
If there's no other questions, we'll just wrap this up. I want to thank everyone for joining us, and thanks, Kevin, for giving us your time. This will be on demand, like I said earlier, so give us a day to get this uploaded, and we'll be sending out the recording to everyone. Thanks again, and thanks again, Kevin.
Perfect. Thank you, everybody. And if you're
Thanks.
going
Have a good day.
to PASS, I'll see you there.
For sure. See ya.